Thank you. Hello, everyone. I'm Qiuyu from Tsinghua University. And today I'd like to talk about our work, LIME, liquid metal interfaces for non-rigid interaction. And there are lots of research about non-rigid interfaces. And the interfaces are flexible and can change their shape, texture, and so on. They enable new semantics of interaction. However, they are still solid or semi-solid. And we have been thinking of interfaces and that is much more flexible, like an interface based on liquid. When we talk about liquid, we love its flexibility, continuity, and beauty. Here are some examples of art and design works. As we can see, so many streamlined and curved surfaces are around us, and they look just like frozen running water. Moreover, in myths, legends, animations, and movies, there are so many things that people imagine interacting with liquid through some sort of magic or future technique. To get closer to these imaginations and to develop liquid-based interfaces, we have done lots of research, and we found a very special material. It is liquid metal, gallium indium alloy. Compared with mercury, it is safe to human and can be produced through a simple process. Besides, researchers have found some special properties of the liquid metal. It can deform and move with electrical field when in alkaline solution. The phenomenon is caused by the change in surface tension. In general, when under electrical field, oxide combines on the surface of liquid metal, and the surface tension declines. And after the electrical field is removed, the oxide will be chemically dissolved by the solution, and the surface tension weakens worse. With this special mechanism, we are able to develop new non-rigid interfaces. These interfaces enable new interaction styles, and we name them LIME. To work normally, the LIME interfaces require electrical field and solution environment. So we develop a series of containers with electrodes embedded. And we call them LIME cells. They are building bricks for the LIME interfaces and have three basic forms. The open cell is very small, and the liquid metal droplets can deform to fully cover the bottom on the electrical stimulus and shrink to almost invisible when stimulus removed. The second one is a curved cell. Since liquid metal has very high surface tension, it can be felt when touched. And the curved cell has a thin lid on it, allowing users to touch and feel droplets safely. The last one is the tunneling cell. It has a tunnel for liquid metal to transfer. And if the tunnel is narrow enough, it will only allow electrically controlled transfer. Based on the LIME cells, we designed some LIME widgets. And with these prototypes of interfaces, we explore some new interaction styles. This is a shutter. It is a matrix of open cells, which can switch between transparency and opaqueness. It can work as an attached information layer and add new interaction styles to physical objects, like mixed texture, fancy revealing effect, and highlighting. A physical checkbox has a row of open cells. With different status of liquid metal, it can indicate either a task is finished, undone, or ongoing. A physical radio button is composed of tunneling cell. The liquid metal droplet in it can traverse to a specific position and make emphasis. We also made a prototype of weight changing widget with tunneling cell. You see, since liquid metal has very high density, users can feel the weight change. Users can feel the weight change when holding the widget in hand. The ball are some sort of physical augmented expression widget. Besides, we also developed some manipulation widget. For example, this is a 3x3 coupled cells matrix. We can control specific pixels to change their surface tension and deform, so that it can provide significant difference of touch feedback. And it can create keyboards with different layouts. Even with just one cell, a controlling widget can perform like a thumbstick. Furthermore, combined with tunneling cell, we even make a physical slider and a physical knob. To sum up, we have explored many interactions online, and we can put them into two galleries. The first gallery is visual effect. The interface can hide or reveal information behind it, and the flickering or movement of droplets can draw attention. The second gallery is haptic feedback. You see, the feedback is dynamic. For instance, it can provide strong or weak haptic perception through switch off or on the electricity. At last, I want to talk about some other interesting facts. Firstly, as mentioned before, the tunneling cell with a very narrow tunnel will only allow electrically controlled transfer. Well, traditionally, we think that actuation of system should be weaker than the manipulation of hands. But in this case, the very simple pushing task is hard to the hand, but easier to the system. And here's another interesting. It is the unpredictable shape change. Actually, we have met some bugs in the earlier stage of experiment, and the stimulus is not very stable. But we accidentally found that the liquid metal began to dance. These findings remind us from time to time that there are still many potential for Lime interfaces that we haven't explored. So that's my presentation. Thank you.
A question over there. Hi, nice project. I was thinking, because the material you're using is the melting point is 15 Celsius degree.
Yeah.
I was thinking if you have like experimented doing like a phase shifting, making fluid to solid, and
yeah.
if you are also thinking how you can use, if you have thought about it, how you can use this phase shift for application, those stuff. That's the question.
Yes, actually we have think about. You see, it's a melting point now is 15 centigrade. But you can change it if you change the ratio of the two different metals. And we have think about to utilize this and add some heating or cooling system so that there could be a stiffness change system. For like the widget, we called it haptic feedback widget. If we make it into cool it and it come to solid, it will provide a much obvious perception of haptic feedback that is in liquid space. Thank you.
Are there any other questions? If there are no other questions, let's thank the speaker.